There is a body of water in eastern Indonesia that sits at the center of one of the most consequential stretches of ocean on Earth, ringed by islands that were once the only source of something that kings paid fortunes to possess, that navies were built to control, that changed the economic map of the entire world. And the approach to that body of water from the west, the corridor of sea and island and reef and depth that connects it to the wider Indonesian archipelago, is one of the least systematically documented marine regions on the planet. Not because it is small, not because it is insignificant, but because the combination of extreme depth, complex current systems, the presence of active volcanic geology, both above and below the water, and centuries of deliberate cartographic avoidance by colonial powers, who preferred that competitors not know what they knew, has left this corridor in a state of documentation so incomplete that modern oceanographers still argue about what is actually down there. The Banda Sea itself is extraordinary, but the Western approach, the way in, is the thing that almost nobody talks about. And when you start pulling on the thread of why that is, when you start looking at what has actually been documented there despite the historical reluctance to map it, what you find is something that changes the way you think about how the world is known, and how much of it is not. Subscribe right now if you want to see the world the way it actually is, not the version on the surface, not the version on the official maps, but the real depth of it, the part that took centuries of silence to accumulate and is only now beginning to be spoken. Let us go. To understand what the Western approach to the Banda Sea actually is and why it matters, you need to understand the Banda Sea itself first, because the approach only makes sense as a corridor to somewhere, and the somewhere in question is one of the most remarkable enclosed bodies of water on the planet. The Banda Sea is a deep, roughly circular basin in the eastern part of the Indonesian archipelago, surrounded on nearly all sides by islands and island arcs and the complex geology of a place where several major tectonic plates are in active, ongoing collision. The sea covers roughly 480,000 square kilometers, which makes it substantial, but not enormous in global terms. What makes it extraordinary is its depth. The Banda Sea contains some of the deepest water in the entire region, with the Weber Deep located within its basin, measuring approximately 7,440 meters, which makes it one of the deepest points in the world outside the major ocean trenches. That is more than 7 kilometers of water column above the seafloor. 7 kilometers of dark, cold, pressurized water, largely unexplored in any systematic scientific sense, sitting in the middle of one of the most biologically diverse marine regions on Earth. The islands that surround the Banda Sea are the Banda Islands at its center, the Maluku Islands in a broad ring around it, the Tanimbar Islands and the Aru Islands to the south and southeast, Seram and Buru to the north and west, and the long arc of Flores and the Sunda chain running westward. The volcanic geology of the region is not a background fact. It is the most important fact. The Banda Sea exists because of a process of tectonic collision and subduction that has been running for millions of years and is still running, actively, producing earthquakes and volcanic eruptions, and the slow geological reshaping of the landscape above and below the water that makes this one of the most geologically dynamic places on Earth. The Banda Arc, the curved chain of volcanic islands that defines the southern and southeastern boundary of the Banda Sea, is the surface expression of a subduction zone where oceanic crust is diving beneath the region at a rate that is geologically rapid. The volcanoes of this arc, Gunung Api and the Banda Islands being the most famous and the most historically significant, but not the only one by a long measure, are the result of this process. They produce eruptions of varying styles and scales, and they produce hydrothermal activity on the seafloor that is both geologically important and biologically extraordinary, because where there is hot water and mineral-rich fluid venting from the seafloor, there is life. Life that exists in total darkness and operates on chemistry rather than on sunlight. Life that is among the most alien-seeming of anything we have found on this planet. Now, the Western approach. What is it precisely, and why does it matter that it has been so poorly documented? The Western approach to the Banda Sea is not a single channel or a defined strait in the way that, say, the Strait of Lombok or the Strait of Makassar is defined. It is a zone, a broad corridor of water and island and shallow bank and deep channel that extends from roughly the Flores Sea and the Banda Sea junction westward through the waters between Seram, Buru, and the islands of the Central Maluku Group. It includes some of the most complex underwater topography in the region, a series of ridges and basins and seamounts and submarine canyons that are the product of the tectonic complexity of the area, and it carries the primary flow of water that enters the Banda Sea from the west and northwest, which means it is central to the oceanography of the Banda Sea itself. The Indonesian throughflow, which is the global term for the massive movement of water from the Pacific Ocean through the Indonesian archipelago into the Indian Ocean, passes partly through this region. This is not a minor oceanographic curiosity. The Indonesian throughflow is one of the most significant current systems in the entire world ocean, transporting on the order of 15 to 20 sverdrup of water, which is a unit of measurement so large that it encompasses the combined flow of every river on Earth many times over, from the Pacific into the Indian Ocean, where it influences the thermocline structure of the Indian Ocean, and therefore the monsoon systems, and therefore the rainfall patterns and agricultural productivity of a significant fraction of humanity. The western approach to the Banda Sea is one of the regions through which this globally significant flow of water moves, and it is documented with a level of precision that is, to put it plainly, inadequate to the importance of what is happening there. Part of the reason for this inadequacy is historical, and the history is one of the most dramatic and consequential stories of colonial competition that the early modern world produced. The Banda Islands, which sit at the heart of the Banda Sea, were for several centuries the only place on Earth where nutmeg grew. Nutmeg and mace, which is derived from the same fruit, were among the most valuable commodities in the global spice trade of the 15th, 16th, and 17th centuries, valued at prices that are almost impossible to translate into modern terms, but which made the Banda Islands, a tiny scattered group of volcanic islands in a remote corner of the eastern Indonesian archipelago, among the most economically significant pieces of real estate on the planet. European powers, first the Portuguese, then the Dutch, then briefly the English, competed for control of the nutmeg trade with a ferocity that produced some of the most brutal episodes of colonial violence in the history of the spice trade era. The Dutch East India Company, the VOC, achieved dominance over the Banda Islands in the early 17th century, and its method of securing that dominance was comprehensive and catastrophic. The Bandanese people, who had governed their own trading networks across the Banda Sea and beyond for centuries, were essentially destroyed as a population through a combination of warfare, massacre, and the deliberate destruction of their food supplies and livelihoods. The population of the Banda Islands before Dutch conquest is estimated at around 15,000 people. Within a few decades of Dutch control being established, that population had been reduced to the hundreds. It was one of the earliest and most complete instances of what we would now recognize as genocide in the colonial era, and it produced a set of islands that the VOC then restocked, with enslaved people brought from other parts of the archipelago to work the nutmeg plantations, called perken, which the VOC divided among Dutch and mixed heritage colonists called perkeneers. The point for our story is what the Dutch did with geographic information about the Banda Sea and its approaches. They kept it, they classified it. They treated the navigational knowledge of the Banda Sea, the knowledge of its currents and its reefs and its safe anchorages and its dangerous shallows and its channels, as a proprietary asset, because that knowledge was the operational foundation of the nutmeg monopoly. If a rival power did not know how to navigate to the Banda Islands, it could not threaten the Dutch monopoly on nutmeg. The cartographic suppression of the Banda Sea was therefore a deliberate commercial strategy. Maps were produced, but they were not published. Charts were compiled, but they were kept in the VOC archives. The western approach to the Banda Sea, the corridor of water through which any challenger would need to pass to reach the Banda Islands from the west, was a strategic secret. This has consequences that echo forward in a way that seems almost implausible. The Dutch suppression of Banda Sea cartography in the 17th and 18th centuries was so thorough that the accurate mapping of the region's marine environment was delayed by generations compared to other parts of the world ocean that attracted more open scientific attention. When modern oceanographic surveys began to systematically study the Indonesian archipelago in the 20th century, they found that the baseline cartographic record for the Banda Sea region was substantially less complete than for comparable bodies of water elsewhere, because the historical record had been deliberately incomplete and the gap had never been fully closed. The bathymetric mapping of the western approach, the mapping of the actual depth and topography of the seafloor in this corridor, remains, even now, at a level of resolution that scientists who work in the region describe as inadequate. The GEBCO, the General Bathymetric Chart of the Oceans, which is the most comprehensive global dataset for seafloor topography, shows the western Banda approach region at a resolution that reveals major features, but leaves the detailed topography of significant areas uncharted. Seamounts, underwater volcanic mountains, have been identified in the region that have not been systematically surveyed. The ridge and basin structure of the seafloor in the approach corridor is known in outline but not in detail. And in a region of active volcanic geology, where the seafloor is not static, where new features can be produced by volcanic activity on timescales of years rather than millennia, the gap between the known and the actual is not merely an academic inconvenience, but a practical problem for navigation, for submarine cable routing, and for the scientific understanding of one of the most oceanographically significant corridors in the world. Let us talk about what has actually been documented there, because that is the other half of the story, and it is extraordinary in its own right. The biology of the Banda Sea and its western approach is among the most thoroughly documented aspects of this underdocumented region. And what the biological surveys have found is evidence of a marine ecosystem of staggering complexity and richness, sitting in an environment of extreme physical conditions that should not, by simple intuition, support such richness but does, because the relationship between depth and productivity and current and biology in this region operates by rules that are still being worked out. The coral ecosystems of the Banda Sea approach region are among the most diverse on Earth. The area sits within the Coral Triangle, the roughly triangular region of tropical western Pacific Ocean that encompasses parts of Indonesia, Malaysia, the Philippines, Papua New Guinea, the Solomon Islands, and Timor-Leste, and which contains the highest marine biodiversity of any region in the world. More species of reef fish, more species of coral, more species of marine invertebrates live in the Coral Triangle than anywhere else on the planet. The species counts are not marginal differences. The Coral Triangle contains approximately 6 times the number of coral species found in the Caribbean. It contains roughly 3,000 species of fish, compared to the Caribbean's fewer than 1,000. It is, in biological terms, the Amazon basin of the ocean. Within the Coral Triangle, the Banda Sea approach region is not the most celebrated subregion, not in the way that the waters around Raja Ampat in West Papua have become famous in marine biology and diving circles. But the waters of the Seram Sea and the approaches to the Banda through the Maluku Island groups contain documented communities of corals and fish and invertebrates that are as complex and diverse as anything found anywhere in the triangle. Deep reef surveys, using remotely operated vehicles and submersibles capable of reaching the depths, where the light begins to fail, and the coral communities shift from the photosynthetic communities of shallow reef to the filter-feeding communities of the mesophotic zone, the twilight zone between 30 and 200 meters depth, have documented species communities at these depths in the Western Banda approach that include species new to science. This is worth pausing on. New to science means not previously described in the scientific literature, not known to Western taxonomy, not assigned a Latin binomial name and a place in the phylogenetic tree. The deep reefs of the Western Banda Sea approach are producing species that nobody knew existed until very recently, and surveys of these depths are still not systematic or comprehensive. The mesophotic zone of this region is, in the formal scientific sense, incompletely known. The surveys that have been done have found enough that the scientists doing them are clear that what has not been surveyed almost certainly contains things of equal or greater interest to what has. There are documented aggregations of fish in the waters of the Western Banda approach that are significant enough in ecological terms to have attracted the attention of fisheries managers and conservation organizations. The Banda Sea tuna fishery, one of the most productive in Indonesian waters, is connected to the oceanographic conditions of the Western approach, where the upwelling of cold, nutrient-rich water from depth creates a bloom of productivity that supports the forage fish that support the tuna. The mechanism of this upwelling is itself connected to the current systems of the approach corridor, to the way that the Indonesian through-flow water moves through the channels and over the ridges and around the islands of the Western Banda region, pushing deep water upward in a process that fertilizes the surface ocean with nutrients that would otherwise remain locked in the deep. The upwelling of the Banda Sea is documented. It appears in the oceanographic literature going back to early 20th century German and Dutch scientific expeditions. But the specific dynamics of the Western approach contribution to this upwelling, the precise pathways through which the current moves, and the precise locations where it meets the bottom topography and rises, are known only in general terms. The detailed mechanism awaits the kind of high-resolution current measurement and bottom mapping that has not yet been systematically applied to this corridor. What has been documented about the Banda Sea's hydrothermal activity is among the most geologically fascinating aspects of the region. The seafloor of the Banda Basin and its margins is not geologically inert. The tectonic processes that created the basin are ongoing, and the volcanic arc that defines the southern Banda Sea boundary is, as already noted, actively producing eruptions and seismicity. What this means for the seafloor is that hydrothermal systems, vents through which hot, chemically enriched water seeps or jets from the seafloor, are almost certainly present in multiple locations in the Banda Sea region, including potentially in the Western Approach Corridor, where the submarine ridges provide the kind of geological structure that is associated with hydrothermal activity. Confirmed hydrothermal activity has been documented in parts of the Banda Sea. What has been found at confirmed sites is consistent with what hydrothermal vent systems look like elsewhere in the world ocean. Communities of chemosynthetic organisms, organisms that derive energy from chemical reactions rather than from photosynthesis, organized around the vent openings in dense assemblages that are among the most striking of any biological community on Earth. Tube worms, clams, mussels, shrimp, crabs, and microbial mats that form the base of the food web in these ecosystems, all present in the darkness and heat and chemical richness of the vent environment, all dependent on the geology for their survival rather than on sunlight. The species found at hydrothermal vents in this region of the Western Pacific are not necessarily the same species found at vents in the Atlantic or the Eastern Pacific. The biogeography of hydrothermal vent communities is a relatively young scientific field, and the questions of how vent communities in isolated deep basins like the Banda Sea are connected to or isolated from vent communities elsewhere in the world ocean are actively being worked out. The Western Banda approach, with its combination of deep water, active geology, and complex current pathways, is precisely the kind of region where new information about hydrothermal biogeography could fundamentally revise our understanding of how deep-sea vent life is distributed and connected across the world ocean. But the surveys have not been done at a scale that would generate that information. There is a specific feature of the Western Banda approach that has attracted scientific attention in recent years, and that represents one of the clearest examples of how much remains to be documented in this corridor. It is the structure of the seafloor along the Seram Trough, a deep basin that runs along the northern margin of Seram Island and connects the waters north of Seram to the broader Banda Sea region to the east. The Seram Trough reaches depths of several thousand meters, and its bottom topography is complex, with ridges and scarps and what appear from existing sonar data to be landslide deposits of considerable scale. Submarine landslides in this region are not merely a geological curiosity. The Banda Sea region has experienced some of the largest earthquakes in the recorded history of Indonesia, and large earthquakes in regions of steep submarine topography are capable of triggering submarine landslides of sufficient scale to generate tsunamis. The relationship between the seafloor topography of the Western Banda approach, the earthquake geology of the region, and the tsunami hazard for the coastal communities of the surrounding islands is a connection that seismologists and tsunami scientists have identified as requiring much better seafloor data than currently exists to properly evaluate. The communities on the coasts of Seram, Buru, Ambon, and the other islands of the Western Banda approach region are communities of real people, fishing villages and small towns, and the city of Ambon itself, and their exposure to tsunami hazard from the adjacent seafloor is a question that cannot be fully answered with the current state of bathymetric knowledge. This is where the historical cartographic deficit ceases to be merely an interesting story about Dutch colonial strategy and becomes something more pressing. The unmapped or poorly mapped seafloor of the Western Banda approach is not only of academic scientific interest, it is a gap in knowledge that has practical consequences for real people living in a seismically active region where the tsunami history is already a matter of documented tragedy. The 1674 Banda Sea earthquake and tsunami, which is among the earliest well-documented tsunami events in the Indonesian historical record, killed an estimated 2,000 people and destroyed communities on Ambon and surrounding islands. The 1852 earthquake in the Banda Sea region produced a tsunami that affected communities across the eastern Indonesian archipelago. The 1938 Banda Sea earthquake, one of the largest recorded in the 20th century, at a magnitude estimated between 8.4 and 8.5, generated a tsunami that affected the coastlines of the Banda Arc. These are not ancient geological events whose records are uncertain. They are historical events that are documented in colonial administrative records, in missionary accounts, in early scientific literature. They establish a pattern of seismic and tsunami hazard in this region that is as clear as any in the world ocean. And yet the seafloor that generates these events, the seafloor of the western approach in the Banda Basin, is mapped at a resolution that does not allow scientists to fully characterize the fault systems and submarine slopes that are the immediate mechanisms of the hazard. This is the consequence of centuries of incomplete documentation, and it is a consequence that is measured, in the worst cases, in lives. Beyond the geology and the oceanography and the biology, there is a human history connected to the western approach to the Banda Sea that is as rich and as incompletely documented as any of the physical aspects of the region. The peoples of the Maluku Islands, the people of Seram and Buru and Ambon and the Central Maluku Group, have been navigating the waters of the western Banda approach for thousands of years before any European vessel passed through this corridor. The Austronesian expansion, the prehistoric movement of peoples from the island of Taiwan southward through the Philippines and into the Indonesian archipelago and beyond, across the Pacific to Polynesia and westward to Madagascar, is one of the most extraordinary episodes of human migration in the history of our species. The Maluku Islands were part of this expansion. The people who settled the islands of the Banda Sea region arrived by sea, navigating in outrigger canoes across open water, guided by star knowledge and wave patterns and bird behavior and current signatures, with a navigational tradition that was sophisticated enough to colonize the most remote island groups in the entire Pacific Ocean. The maritime culture of the Maluku people reflects this navigational heritage. The traditional boat-building traditions of Seram and Ambon and the surrounding islands, the knowledge of the sea encoded in the navigation traditions of communities that have been crossing these waters for millennia, the trade networks that connected the Banda Islands to the wider archipelago and to the Asian mainland through a web of exchange that pre-existed the European spice trade by centuries. These are all aspects of the human history of the Western Banda approach that are documented in the anthropological and historical literature, but remain, in many respects, incompletely understood. The oral histories of the communities of Seram, for instance, contain accounts of a deep past, a time before the arrival of outside traders, before the nutmeg trade became the organizing principle of life in these islands, when the political and social structure of the island was organized according to principles of alliance and kinship that operated across the sea. The Pella and Gondong systems, traditional forms of alliance between communities on different islands in the Maluku region, which bind villages together across the sea in relationships of mutual obligation and solidarity that have persisted through centuries of colonial disruption, are a form of social geography that maps the Western Banda approach in human rather than cartographic terms. A Pella alliance connects two or more villages, often on different islands, through a bond that is understood as sacred and permanent. The villages are forbidden to intermarry, but are obligated to help each other in times of crisis, to share resources, to welcome each other's members as family. The geographic pattern of Pele alliances in the Maluku Islands maps the sea routes and the social networks of the pre-colonial maritime world of the Banda approach, encoding in living social practice the connections between communities that the physical geography of the sea both enables and complicates. This is a form of knowledge about the Western Banda approach that exists nowhere in any oceanographic or bathymetric database. It is knowledge carried in the social memory of communities, in the practices and obligations that bind villages across the water, in the specific understanding of which island is the brother island and which is the grandfather island, and why, according to a history that stretches back past the point where any outside record begins. The Pella system is documented in the anthropological literature, but that documentation is itself incomplete, the product of fieldwork done at specific times and places, rather than of any comprehensive survey of a living social tradition that continues to evolve. There is another dimension of the Western Banda approach that has been documented in ways that are as striking as any of the scientific findings, and it is the dimension of language. The Western Banda approach region contains a concentration of linguistic diversity that is, by the global standards of linguistic geography, extraordinary. The island of Seram alone, a single island of approximately 18,000 square kilometers, contains multiple distinct languages, not dialects of a common language, but languages as different from each other as English is from Turkish. The Maluku Islands, more broadly, contain dozens of distinct languages from the Austronesian family, arranged across the islands in patterns that reflect the history of settlement and contact and isolation and exchange over thousands of years. Some of the languages of the Western Banda approach region are spoken by very small communities, a few hundred people, sometimes fewer, on islands or in inland valleys, where the combination of geographic isolation and historical disruption has resulted in the survival of languages that document ancient aspects of the Austronesian expansion, or of even earlier human presence in the region. The documentation of these languages, the basic linguistic work of recording vocabulary and grammar and oral literature before the speakers of the language shift entirely to Indonesian or regional lingua francas, is a scientific and cultural priority that is recognized but not adequately resourced. When a language dies, when the last speaker of a language dies without having transmitted the language fully to anyone else, the loss is not merely sentimental. A language is a system of knowledge, a system for categorizing and describing the world that has been developed and refined by a community over thousands of years of experience in a specific environment. The languages of the fishing communities of the Western Banda approach encode knowledge of the sea, of the species that live in it, of the seasonal patterns and the current changes and the storm signs that has been accumulated through generations of intimate observation of this specific body of water. When those languages disappear, that knowledge disappears with them, unless it has been explicitly recorded in a form that preserves not just the vocabulary, but the context and the practice in which the vocabulary is embedded. The ethnobiological knowledge of the communities of the Western Banda approach region is itself a form of documentation of the marine environment that scientific surveys have only partially accessed. The fishing communities of Seram and Buru and Ambon and the smaller islands have their own detailed taxonomy of the fish and corals and other organisms of the Western Banda Sea, based on morphology and behavior and seasonal pattern, encoded in the local languages and in the practical knowledge of how and where and when to fish for each species. This taxonomy does not always map exactly onto the scientific taxonomy, sometimes describing distinct species that science has lumped together, or distinguishing behavioral forms that science has not formally recognized, but it represents thousands of hours of careful observation of the marine environment by people whose livelihoods depended on the accuracy of their knowledge. Ethnobiological research in the Maluku region has documented some of this knowledge and found, in several instances, that local knowledge pointed toward biological features of the marine environment, the locations of specific habitats, the seasonality of specific behaviors, the presence of specific species in areas where scientific surveys had not yet found them, that were subsequently confirmed by formal scientific investigation. This is not surprising to people who work in the intersection of traditional ecological knowledge and marine science. It is a pattern that has been documented in many parts of the world, the pattern of local knowledge providing a useful guide to scientific investigation in environments that science has not yet fully characterized. In the Western Banda approach, where formal scientific surveys are incomplete, the local ecological knowledge of the fishing communities may represent one of the most detailed bodies of information about the marine environment that currently exists. The implications of this go beyond the purely scientific. If the communities that carry this knowledge are economically marginalized or disrupted by overfishing or climate change or migration to urban centers, the knowledge goes with them. The fishing community that abandons the Western Banda approach for the opportunities of Ambon or Makassar or Jakarta does not necessarily take its detailed knowledge of the marine environment with it in a form that is accessible to anyone else. The knowledge is embedded in practice, in the daily act of going out on the water and applying accumulated observation to the problem of finding fish. Remove the practice, and the knowledge becomes inaccessible, even if the person who carries it is still alive. This is the human dimension of the documentation gap in the Western Banda approach. It is not only that the scientific surveys have not been done, it is that the local knowledge systems that could complement and inform those surveys are themselves under pressure from the economic and social changes that are drawing people away from the specific practices in which the knowledge is embedded. Let us turn to what has been documented about the fish themselves, because the fisheries of the Western Banda approach are, from a global perspective, among the most significant wild fisheries remaining on Earth, and the documentation of those fisheries has a particular story that illuminates the broader question of how this region is known. The yellowfin tuna fishery of the Banda Sea is among the most productive in the world. The upwelling dynamics of the Banda Sea, driven by the seasonal reversal of the Indonesian monsoon and the oceanographic processes of the Western Approach Corridor, produce a seasonal bloom of productivity that supports large aggregations of tuna in the waters of the Banda Sea and its approaches. The traditional fishing communities of the Banda Sea region have been exploiting this productivity for centuries, using handline fishing methods from small wooden boats, methods that are selective for tuna and that have relatively low bycatch compared to the industrial purse seine and longline fisheries that have entered the region in the industrial fishing era. The documentation of the Banda sea tuna fishery is extensive compared to the documentation of many other aspects of the Western approach, because fisheries data, catch records, and vessel monitoring and stock assessments are among the more systematically collected forms of information about this region, driven by the economic value of the fish and the regulatory requirements of Indonesian fisheries law and international tuna management agreements. But even this relatively well-documented fishery has significant gaps. The stock assessment for Banda sea yellowfin tuna is based on catch and effort data that has known gaps and biases, particularly for the traditional handline sector, whose catches are harder to monitor than those of the larger industrial vessels. The relationship between the productivity of the Banda sea fishery and the oceanographic conditions of the Western approach, specifically the variability of the upwelling dynamics from year to year and decade to decade, is understood in general terms but not at the level of resolution that would allow precise prediction of fishery productivity under different climate scenarios. This matters because the climate is changing. The temperature and circulation patterns of the Indonesian seas are already showing changes consistent with global warming trends. And the projections for the region, the projections of how the monsoon and the upwelling and the productivity dynamics of the Banda Sea will change as the ocean warms and the thermal stratification of the water column increases, are uncertain in ways that are directly related to the gaps in physical oceanographic understanding of the Western approach. The models that project future fishery productivity under climate change are only as good as the understanding of the physical oceanographic processes that drive current productivity, and that understanding, for the Western Banda approach, is incomplete. The communities that depend on the Banda sea fishery, the fishing villages of the Maluku Islands, and the Banda Islands themselves are therefore in a position of double vulnerability. They depend on a fishery whose future productivity is uncertain because the physical oceanographic basis of that productivity is incompletely understood, and they have limited alternative livelihoods because the isolation of the eastern Indonesian archipelago and the limited development of non-fisheries economic activity in the region means that the fish are, for many communities, the primary or the only significant source of income and protein. This is the consequence of the documentation gap in the Western Banda approach made concrete and human. The incomplete oceanography of this corridor is not an abstract scientific problem. It is a problem that connects to the food security and economic survival of real communities, whose futures depend on the productivity of a sea that we do not fully understand. There is one more dimension of the Western Banda approach that demands attention, and it is perhaps the most haunting, the dimension of what has been lost before documentation could reach it. The Banda Sea and its approaches have been the site of some of the most consequential and least commemorated events in the history of the colonial era, events that are documented in the colonial archives, but that have received far less historical attention than their scale and significance would seem to warrant. The Dutch conquest of the Banda Islands was, as noted earlier, one of the most thorough episodes of colonial destruction of a human population in the early modern period. But the aftermath of that conquest, the 2 centuries of VOC and then Dutch colonial rule of the Banda Islands and the surrounding sea, produced a social and environmental history that is recorded in fragments in the colonial archives and in the oral traditions of the surviving communities and in the physical landscape of the islands themselves, but that has never been assembled into a comprehensive account. The Perkin system, the plantation system that the Dutch imposed on the Banda Islands after the destruction of the Bandanese population, transformed the ecology of the islands themselves, clearing the native forest that the Bandanese had maintained, and planting nutmeg monocultures that altered the soil and the water systems and the bird communities of the islands in ways that are still visible in the current ecology of the Bandas. The bird of paradise species that were documented in the Banda Islands by early naturalists are no longer present there in the numbers that the early accounts describe. The forest that once covered significant portions of the islands is largely gone. The ecological history of the Banda Islands, the story of how 2 centuries of plantation agriculture transformed a forested island ecosystem into the landscape that exists today, is documented in the scientific literature of historical ecology only in the most general terms. The record of the Western Banda approach is itself a form of documentation that is incomplete and that contains extraordinary historical information. The waters of the approach corridor, The channels between the Maluku Islands, the waters around Ambon and Seram and Buru, were among the busiest maritime routes in the eastern Indonesian archipelago during the VOC era. The volume of shipping that moved through these waters, the volume of trade in spices and cloth and ceramics and metal goods, and the enslaved people who moved through this maritime network as a commodity, was substantial, and the ships of the VOC era were working in an environment of active volcanic geology and strong currents and imperfectly charted reefs. Ships went down. The historical record confirms losses in this region. The VOC archives, now preserved in Jakarta and The Hague, contain records of vessels reported missing in the eastern Indonesian routes, vessels that were never accounted for, vessels that presumably went down in the waters of the western Banda approach or the Banda Sea itself. The archaeological record of these losses, the actual wrecks on the seafloor, is almost entirely unexamined. Maritime archaeological surveys of the shallow waters of the Maluku region have identified some material, potsherds and ceramic fragments and anchors, in the coastal zone, but the systematic survey of the approach corridor for wreck material from the VOC era has not been done. Each unexamined wreck is a sealed context, a deposit of material culture from a specific moment in time, preserved in the cold and dark of the seafloor, containing information about the trade goods and the navigation technology, and the material life of the maritime world of the early modern Indonesian archipelago that cannot be recovered from the documentary record alone. The Dutch archives are extraordinary, but they are incomplete. The VOC captains did not record everything they carried. The cargo manifests do not reflect the entire material reality of a ship. The wrecks do. The question of what the seafloor of the Western Banda approach contains in terms of wreck archaeology is, like so many other questions about this region, one that cannot be answered from existing data. The surveys have not been done. The technology to do them, side-scan sonar and remotely operated vehicles, and the expertise to interpret the results, exists and has been applied in other parts of the world ocean to reconstruct the maritime history of colonial-era shipping routes. The application of that technology to the Western Banda approach is a research agenda that is waiting to be pursued. Beyond the VOC era, the Second World War added its own layer to the wreck record of the Banda Sea and its approaches. The Battle of the Java Sea in February 1942 and the subsequent fall of the Dutch East Indies to Japanese forces involved naval action throughout the Indonesian archipelago, including in the waters of the Banda Sea region. Japanese and Allied naval vessels and aircraft were lost in this region during the campaign, and the subsequent Japanese occupation of the Maluku Islands involved the movement of substantial military shipping through the Western Approach corridor. Some of this shipping was sunk by Allied action. The wreck record of the Second World War in the Banda Sea approach is known in general terms from the historical accounts of the campaign, but the precise locations of many of the losses are not confirmed, and the archaeological survey of the region for Second World War wreck material is not comprehensive. The human dimension of this wartime history is itself incompletely documented. The experience of the Maluku Islands under Japanese occupation, the experience of the communities of Seram and Ambon and the Banda Islands during the years of Japanese control, is documented in the historical literature, but in ways that have privileged the military history over the social history of the occupied population. The impact of the occupation on the fishing communities of the Western Banda approach, on the disruption of the traditional maritime networks and the fishing practices and the social organization of coastal communities by the requirements and the violence of Japanese military control, is a history that lives primarily in the memory of the communities themselves rather than in the formal historical record. The people of Ambon have their own deep history of this period, because Ambon was the site of intense conflict during the early phase of the Japanese invasion, and because the Ambonese Christian community had deep connections to the colonial Dutch administration through the Ambonese soldiers who served in the Royal Netherlands East Indies Army, that made the Japanese occupation a particularly fraught experience. The trauma of the Banda Sea theater of the Second World War is part of the living memory and the community history of the Maluku Islands in ways that are not fully represented in the national Indonesian historical narrative, which tends to foreground the anti-colonial independence struggle rather than the experience of communities whose relationship to the colonial power was more complex. And beneath all of this history, beneath the layers of VOC commerce and colonial destruction and Japanese occupation and independence and the contemporary fisheries economy, the Western approach to the Banda Sea continues to do what it has always done. It moves water. It moves the massive current of the Indonesian throughflow from the Pacific toward the Indian Ocean, through channels and over ridges and around